A very important aspect of acids and bases is to quickly identify towards what direction reaction is going to go. It's going to go a lot to the right, a little bit dissociated, etc. To do that, it's inevitable that we have to memorize some aspects of acids and bases. In this case, we have to memorize which species are going to be the strong acids and which species are going to be strong bases. The list of strong acids and strong bases is short enough so that whatever acid is not in the list of strong acid, it means it's going to be a weak acid. And that's important because if you memorize this list and then your acid is not in the list, again, it'll be a weak acid. A weak acid is an acid that is not completely dissociated to the right towards products. So what reaction does a strong acid have in water? It's completely dissociated. So let's take hydrochloric acid in water. We're going to draw one single arrow to the right, and we're going to draw it like that. Okay. Notice that we are not drawing the back and forth indicating equilibrium. We're going to say it's a strong acid, it's not a weak acid, it's completely dissociated to the right, and the same you can say about all of these, with the caveat here that strictly speaking, sulfuric acid, only the first one is completely dissociated. Only the first proton is completely dissociated to the right. The second one, the second proton, the hydrogen sulfate in water, there's a little bit. It's in most cases you can consider it an also strong acid, but not as much. Okay, that may be the only exception in this list. In most cases, you can consider the second proton of sulfuric acid a strong acid as well. For the strong bases, it's a very easy list to memorize because it's all a metal from the first or second column of the periodic table and an hydroxide. Okay, that is the strong bases that we will deal with, and the reaction in water, notice that you don't even need to include water in here because like an ionic compound, it completely dissociates to the right. The same for magnesium. In this case, notice that you have two hydroxides, but that will be the reaction. All dissociated to the right. There's not going to be any component going back to the left. Very large equilibrium constants. There is a specific reaction that we call neutralization reaction when a strong acid reacts with a strong base. In this case, let's use another one. So when nitric acid reacts with, let's say, calcium hydroxide, a strong acid reacts with a strong base, you'll have water and the salt. In this case, notice that you have two hydroxides, so you're going to need two nitric acids, so that what you create is two waters and the salt. You can either put it in molecular or just exemplifying that this, of course, in water, this is going to be in aqueous. The ions are going to be separated. Okay, that's an important reaction, the neutralization reaction. And what's important too is that the product is going to be water and the salt, and all of them will be neutral. They do not have, and that's something I'm going to talk about in the next slide, the products or the conjugate bases of strong acids are neutral. Let me say more about that. I'm just running it right here. The conjugate base of a strong acid is so weak of a base that is considered neutral. So write the conjugate bases of strong acids. That means that if you have hydrogen chloride is the acid, chloride is the conjugate base. That means that chloride is such a weak base that is considered neutral. In other words, when you mix it with water, do not expect it to behave like an acid, like a base, excuse me, because this guy, hydrochloric acid, is very strong. Okay, so it's neutral. So let's write them all. If nitric is the acid, nitrate is the conjugate base that is very weak to the point that it's neutral. If perchloric is the acid, perchlorate is neutral. Neutral meaning it does not involve in any kind of acid-base reaction. So do not write something like that. Do not expect chlorate to accept a proton. I'm just going to cross it in a minute. Do not expect this to happen, because when you have a strong acid, it means that the conjugate base is so weak it cannot have any acid-base property. Okay, because this reaction would be completely displaced to the left. Alright, we can say more. We said sulfuric acid, maybe the second is kind of strong, but not completely. Sulfate is typically, we can say that sulfate is a neutral ion, okay, and so on and so forth. Okay, we can write them all, but this would be chlorate, again, is neutral, and of course we have the bromide and iodide. I don't know if I forgot one in here. I think I wrote them all. Okay, it's very, very important that you can memorize this reaction, this list, because that will save you a lot of time trying to rationalize why is it that some reactions go to the right and others don't.